Hi, Juwan. How are you? Hope you're doing okay, everybody. How are you doing? Hi, Manuel. Okay, let's see. We're starting in a few minutes. Please check out your lab on Canvas. Let me post the code on there so it's easier for you. Okay. And then I'll walk you through the code. Okay, so let's see. Image. Let me put the image on there for you. Okay, so let's see. Okay, we'll start in a couple minutes. I just added the lab. I posted the code picture on there for you. So that way it's easier for you to follow along. So please download your lab. We'll talk about Fibonacci today. That's what we're going to be doing for the lab today. Only one program.
Not to be a nerd, but I'm so excited for this lab tonight.
Yeah, I normally do a Fibonacci one for this and the CIS11 class, where we write in C++. Speaking of which, I have a minute, so let me pull that up so you can see it in C++. Yeah, I like sequence and series stuff, so because it's easy for student to see it. Let me see, I wrote like 6. So let me find the one that would be parallel to this one in C++. Okay, yeah, this one's okay. All right, so it's 6 o'clock. Welcome back to CIS11. We're gonna do Fibonacci sequence today. And yeah, we're gonna do iterative because that will be the easiest, but there's some recursion that's involved, okay? Like n-1 and n-2. So we'll talk about that. So let me go into screen share. So I had just added the image for the code because I know that when I scroll through the code, sometime if you didn't catch a line, it might throw off your code. So you can refer to the lab page there. The document we're going to talk about now is this one. So if you downloaded it, you can find the information there. Okay, let me minimize my people on Zoom. So let's start with talking about Fibonacci as a set of numbers. So in this lab, we're going to work on looking at the numerical pattern, and we're going to use LC-3. So in this lab, you're going to touch on branching a little bit more. We don't necessarily do subroutine call or anything for this one, but at least we will understand how to use some of the operations. So with Fibonacci numbers, this is a pattern that you would see in sunflower, in shells, in natural, biological, even in the galaxy, you would see Fibonacci numbers. I put a link for the video for TED Talk on there, so if you have the chance, you can watch it. It's pretty interesting. The person that presented on the video, he's one of the math teacher. And he talks about like all this miraculous thing that we see from math all around us. So things that you see with spiral, things that are in design that you see for some of the architectural design, it uses sequence like Fibonacci. And, so Fibonacci is similar to Lucas number or other set of sequence, but with Fibonacci, we would look at, for our lab, we would look at seeding at 1. So we would start with the first n is going to be 1, and we're going to start with seeding 1 and 1 for A and B. So Fibonacci is named after Leonardo of Pisa. He's known as Fibonacci. So, and he introduced this particular sequence, and later on we discovered that this actually was discussed and discovered in India prior, but Western European mathematics was, they know Fibonacci sequence in the later years. So Fibonacci numbers are used in computer algorithm for search algorithm. We use Fibonacci for heap, and we'll touch on heap and stack later. We can also use it for graphs. So if you take my discrete structure class, we'll touch on graphs and how we would look at nodes in the graphs, or the how those nodes would contain values, and that can be carried out in routing, in logistic, in flights, in travel, in a lot of different things that we implement our systems for. And so we see that in our parallel and distributed systems. So it's really important to really dissect and understand the programming side of this. Okay. And outside of the biological things, from pineapple to flower to artichokes, to our galaxy, we in shells, seashells, we see Fibonacci sequence. So now when you look at the sequence itself, okay, how do they derive the later number? Sometimes you would see cases where they would seed at the first two value would be 0 and 1, but in our case, we're gonna seed at 1 and 1. So when you take 1 and 1, you add them together, you would get the next value, which is the third value, which is 2. And in order to derive the subsequent value, you just take the two previous numbers and you add them together. Okay, and that's very easy to do in LC3 or assembly, because we simply just add, looking at the prior numbers and then add them together. And so therefore you often see recursive function being used to generate Fibonacci numbers or Lucas numbers. Okay, so so what we see is, in order to get the next value, we just take the two prior and then we add them and we would get them. So in the case where, if we look at memory allocation, what you have is, when you're looking at the nth value down the line, let's say the 100th value or 180th value, that can be a little bit challenging in that it has to calculate the two prior number in order to generate the subsequent number. Okay, so keep that in mind when you're writing your program. Sorry, my dog is just pushing and he's scared of something. Okay, so now when we look at the equation for Fibonacci, we have f of n, and f of n for Fibonacci is defined as a recurrence relation in that the recursion recursively defines the sequence of multi-dimensional array of values. So when we generate these values, we would then have to store them into an array or a container that would be able to generate all the sequence value or store the sequence value. So f of n is going to be equal to f of n minus 1 plus f of n minus 2. So f of n minus 1 is the first number, f of n minus 2 is the second number. We take those two values and we add it to get the third number. Okay, so here in this lab, we're going to seed at 1 and 1, not 0 and 1. Okay, so now going forward to our problem statement. And we talk about solving problem this week. So it asks you to write an LC-3 program, and we want to compute f of n for the nth value in Fibonacci. And when we complete, we would set this nth value at the memory location. So that way, when we run the program, we would see what that f of n is. Okay. Then we can find the largest f of n so that there is no overflow occurring. And in that, we would have n is equal to the big N, such that f of n is the largest. So we wanted to make sure that there's no overflow in this program. Okay, that's important to keep in mind. And then for our fill, for our location, we need to put f of n at 3101. We can start n at 3100, hex 3100. The big N that will be at hex 3102, f of the big N that will be at hex 3103. And this is the same exact lab that you see from the lab manual from different universities. So now if we're looking at, let's say, if we're starting at with 6, if we set the fill location with the hex 6 or the decimal 6, then we can find the f of 6 at the subsequent location, which is at hex 3101. Okay, and it should give you 8. So just to show you that I had tested some of my values here. So before you run your program today, you need to use the set value button and you need to put in the location, which is 3100, and then you wanted to give it a hex 6. And then you simply run the program. It's going to tell you that f of 6 is 8. Okay. And then at the maximum, right, the maximum value for f of n without overflowing is this. Okay. So that's what our program is going to generate, nothing in the console. Okay. All right. So what we'll do is we will take a look at what's given to us in the listing and we will add that to our pseudocode. So for the first question, it asks you to write the pseudocode for the Fibonacci program. The problem should be solved by iteration using loops as opposed to recursion. Okay, and pseudocode for algorithm to compute f of n shown in listing 4.1. So here, this gives you the hint on how you should incorporate this into your program. So we know that the first two value, we're going to seed it at 1. So when n is less than or equal to 2, then you have f is 1. Else, then you would have a is 1 and b is 1. Then with that, we would nest the for loop, and we want to generate the for loop so that way it will calculate, right? It would operate the addition so we can have f of n. And in the case where, hold on one second. If we look at this in a C++ program, it would look like this, okay? So in a C++, right, in my program, I have a function, and then I would assign what A and B would be, okay? And then for the main, I just have it go up to 9. So in our case, we wanted to go to 6, okay? And so what you do is you have to state where you would start your program, and we have the if statement. Then we would then operate the addition using iteration, okay? So it should output 8 for when n is equal to 6. And there are so many different approaches you can go about doing Fibonacci, but in the iteration process, you would see something like this, okay? And so now you can write it with optimization in mind for the space. Okay, so this program, if you're looking at like the big O, that simply is just your input is really n, right? Okay. All right. So with that, going back to what we have to do here on listing 4.1, it tells you the criteria. We talked about this. So keep in mind that when we work with the for loop, we would have to do a count. Okay, it's going to count up to n. And then, so whatever the n value is, that's going to be the max count for your loop. And when you're trying to find f is going to be equal to a plus b. That's going to represent your function for Fibonacci. And then we would then have to have a is equal to b. So that means that we have to copy the registers. Okay. And then f is going to be, excuse me, equal to b. So now below that, it talks about overflowing. Okay. The way to detect overflow is to use a similar for loop like the listing, which checks f becomes negative. That's important to note. Okay, so we can branch and check for negative. Upon exit of the loop, f does not have the value of f of n. To obtain f of n, you have to slightly modify the algorithm as shown in the next listing. Okay. So here we would have to add 1 to A, 1 to B to represent, right, the seed to start with f of n minus 1 and f of n minus 2. And similar to what you've seen with the C++ program, we would do the index and we would have to start it at 2. Okay. So when we go through this, we first have to do f is a plus b. And then we nest the if condition. If f is less than 0, then n is equal to I. Okay. So looking at this, you should start seeing what you need to do in LC-3, right? And you can pseudocode that out. So I'll walk you through the pseudocode. Okay. So for the pseudocode, and in this one, I didn't really use a label to have the Fibonacci function. You can if you want, and then you just have to call the subroutine. But inside for the operation for Fibonacci, I put that n is the index or the position of the number in the sequence, because when we loop, we want it to loop up to the nth value. And we should fill n at hex 3100. And we would start with n is equal to 1. That is the position for the first number in the sequence, which is 1. And when n is 2, that would be the second position for the number in the sequence, and it is also 1. So those are our seed values. And when we do that, we have to consider adding 1 to our register, right, for the LC-3. And our sequence officially begins at 2. So when you have to be able to consider that the branching when n is greater and equal to 2. So branch positive after comparing 2. Okay. And I forgot to include here that you need to also fill for f of n. And I think that is at hex 3102. Okay. Then to apply the equation, we would then have to use a for loop. In the for loop, we would need to set the counter to n. And as you see in the listing 4.2, we need to initialize I for the index because we want to put the values into an array. And then we would do an I+1 for subsequent loop. So in that task, we have to set the register for I, then add I for increment. Add 1 for increment. Now this function can also be represented as f is a plus b, where a is equal to b. Okay, so when you do a is equal to b, because we seed a and b at 1, we need to add 1 to the register and copy them. Then we would, so that kind of took care of what A and B would be. And to start, okay, before it loops, then we would then have to represent F. So F is going to be equal to A plus B. So you need to operate addition for A plus B. That means we add the registers together. And then in the listing, it tells us that B, we're going to have F is to the B. So we have to copy the register of B to the register of F. Okay. And then I didn't put the last part, which is we want to store values to label. And then that's how we're able to finish and check. Okay, so this program is not very long. So let's go through it real quick. Do you have any questions so far? I'll leave it on here for like a little bit so you can. So basically, when we write out the subtask, right, we just basically mapping out all the criteria to generate Fibonacci sequence, how we would solve it. Any questions? So I tried to add the comments into the code so that way you can see what's happening in different sections. Okay. And you can please feel free to edit the comment to your liking, so that way it helps you remember certain things. And later on, we will do recursive function. So with the recursion and using multiple functions in our program. So this one is a very easy one, just showing you how you can use a loop. Like what we've done last week, we also use loop there. Okay. Questions on this? Okay. So required that you need to put together pseudocode and then add that as part of the exercise 1 for our lab. Then we can write the program. Okay, next then we'll move on to the code, and I posted the code in an image of it in your lab assignment. Okay, so all of this information you can also find in the lab document itself, right? It tells you what you need to include in your program, and then you simply use the listing and then take that, divide it into the subtasks, and then with that you wanted to make notes of what you would do in LC3. So break it down to smaller tasks. Okay, so now I'm going to move forward. Okay, so just like all LC3 program, we would start at the origination address at hex 3000. We first would load the label small n to register 1. And if you like, you can clear register 1 before it. That's fine. I didn't have that line there. So you simply do an AND R2 with the 0, then you would clear. Next, we would clear register 2. Then after that, we would then add 1 to register 2. So register 2 is at 1. That's going to be your n is equal to 1. And I think I have that incorrect. Okay, then next we're gonna add -3 to register 2. And here, what we're doing is we are gonna check for n is less than or equal to 2. And so we want to branch as we check this. So we would check for n is less than or equal to 2 when we add these together. So it should be -2 there. So what does that do for us, right? This represents what? N minus 2. Let me change this. That's going to confuse you. So this is N minus 2. Right? Because we have the N in register 1, and after we add this together, with register 1, we would have n minus 2. Now we're going to branch for positive. So if it finds the positive value, it's going to go to positive. Okay. So when you set your input for n, let's say I set it at 8, right? It's going to take that 8 and then it's going to subtract 2, which gives you 6. That would be a positive, then it's going to go to positive. Okay, so this branch is going to be dependent on your input of the small n. So now, once we have the branch for positive, we're going to clear register 4 or initialize register 4, same. We're going to add 1 to register 4, and this represents f is equal to 1. If it is negative, we're going to stop. But here is where we would check, right? Let me take that out. Actually, yeah, I'll leave it there. Okay. Then what we're going to do is we're going to store register 2 to f of n. Okay, and recall register 2 would hold that n minus 2. Then we do an unconditional branch to skip. And skip just means halt. It's going to stop. Okay. In the positive section for that label, we clear register 2. We add 1 to register 2. That would represent a is equal to 1. We clear register 3. We add 1 to register 3. So here is where we seed. Okay, and that will be b is 1. And then we would add -2 to register 1 and put the result in register 5. So recall that real register 1 holds n. Here we would have n minus 2 in register 5. Okay. Now I have another label called FAB. And this is where we would do the loop. Okay, the for loop for AB. So here we have register 2 plus register 3, and that would be A plus B, right? Because we previously had A plus B in register. A is register 2 and 3 is B. So you add them together and you put them on register 4, and register 4 represents F. We want to copy A and B. So here you have A is equal to B. And then we copy B to F. So now we would do add R3, R4 with the 0. Okay. And then we count down from our loop. So you subtract 1, and then we branch. As long as it's positive, it's going to keep going. So we branch back to FAB again, FAB again. Any question with this? Okay. So after we branch positive, then we would do a store for f of n. And recall that that comes from register 4. Then we clear register 2, and we add 1 to register 2, which is 8. Okay, so what you see is we are addressing the criteria that's stated in the listing, right, in your document. That's what we're going through. Then after that, we would clear register 3 again. Then we would add 1 to register 3 to represent B. Then we clear register 5. And now we would then add 2 to register 5. Now we have to do an overflow check. Okay, so the next part for the FAB2 is for overflowing control. So in this section, we simply use add R4, R2, R3, because that R2 and R3 are A and B, and R4 represents F. If it branch and for negative, then we send it to the negative section. Here we do a copy of AB, a copy of BF, and the increment with I. And again, we branch back to FAB2 if it's positive. Since earlier we stated there's a neg for branching negative, you would then have to say what that is, right? Otherwise, it's going to throw an error. So in the neg, we clear R6. We make R6 as I, so we copy I to R6. And we store that out as big N and F of big N. So the last portion, what you see is overflow control, right? Where earlier, that simply is just generating the calculation. And then the last part would just be skip, which is halt, and then your fill, which is given to you in a document. Okay, any question? Now, it's important that you remember clearing your register, because don't always assume, because if you don't, the only one that we didn't clear throughout, if you look, is your register 1 because it holds N. Okay. The rest of them were reused, and whenever you use it in the label, right? So logically, you have to think about how the registers are used throughout the label. If they're being reused in the label, make sure you clear them, right? If it's supposed to hold a different value. Clarify fab is just a label name, correct? Yes. FAB is just a label name, and you need to use a label to get it to loop. You can call it anything you want. I just use FAB so that way I know what that section is. Yep, the variable FAB. And so, so we just want to put in the label that would be relevant for that section so we don't confuse ourselves, right? And the FAB2, that is just for the big N, right? The loop for the big N. Okay. You can do an add -3. So it's just like, okay, so Lewis says, I thought decimal numbers were only 0 through 9, but I saw you add -3. Yeah, so in the last few lab, we started working with, on LC3, it lets you do the negative decimal, like what we did with the ASCII conversion 2 lab back, right? When you subtract like a decimal value, so you can do it that way instead of doing like the 2's complement. You can do the 2's complement, it's just 2 additional line. Okay. And then ultimately, don't forget the .n at the end of your program. Okay. So yes, you can use, going back to the question, you can use the negative decimal like this. Okay. But if you use hex, it's not going to understand what that is. So if you wanted to do 2's complement, you simply add +3 to the register 2, not it, and then add a 1. And it's still going to do the same thing. It's just, I wanted to save 2 steps, right? So you can do it like this. And we simply wanted to show that it's we wanted to do the subtraction right here. And we wanted to check. Yep, that's correct. So tracking your registers is important. Jason mentioned that it saves the register usage, right? If you reuse register, and notice that I stick with the same register throughout so I don't confuse myself. Okay, because if you start using like different register throughout, so if you say, okay, A is going to be register 2, stick with it throughout, because otherwise you're gonna get like, oh, which register is this, right? And often I would use like the later register for like index or things, like when we start doing stack, we would start using 5, 6, and 7 more. But for the earlier ones, I normally go with like register 1 for the input, and then I keep it uniform so that way I don't lose track of my register and the variable. Okay. And if you didn't get all of this, when I scroll through, you can see the lab canvas page. It shows the complete code in LC3. Okay, so that would look like this. And then Once you have everything together, you would then assemble, right? Translate, assemble. So you can convert it to the OBJ file, and then you would use that to load. Make sure that you check to see if there's errors. Now you can section your label separately to make it clearer for you. I did this so that way I can screenshot it for you guys where it would keep it. Otherwise, the spacing makes it really long and I can't screenshot it all in one piece. But it's better if you just like section it like this. And so that way you don't mix up the line. Okay, so it's cleaner. Okay, so when you use label, tab it. I know that at the beginning we didn't really do that. You can drop it onto the next line. It doesn't really matter with LC3 because it's not space sensitive like that, right? It doesn't care about white space like that. So, but if you tab it, it just look better and it's easier to debug if you go back to certain label. Okay, so anytime you edit your code, you need to reassemble, keep in mind, right? And once you assemble your code, then you can load it. But before you run it, you need to set the value. Okay. So to set the value, you simply use the set value button, right? And then anytime that you recheck, make sure that we reinitialize the machine, load the program, find your object file, and then before you run, make sure that you click set value, and then for the location, just set the location for n. Okay, and then the value you can use hex. So I think it tells us to check with the 6. Okay, click apply. That's the only value you need. And then you click run. Then we just jump to it. And it should tell us 6 here. So when n is equal to 6, f of n is 8. Okay. And if you look at your fill, if you're not sure what 3102, that will be your big N, and your f of n, that will be the largest value that it can hold. So that will be hex 17, and its f of the big N is this value. Okay, then what we want is we can also reset, right? So I'll reload the program, and then I can check for, I meant to do this. And then I can check for like hex when n is 8. Okay. And then run. Then you can jump to. Okay. And it tells you the f of n value. So you notice that it's going to be, there's a ceiling there, right? That's the maximum that's going to hold. So without overflowing. So that's why you see that it doesn't really change. Okay. Now, if you wanted to test it with the larger value, you're welcome to do that. So going back to what you're required to do, right? Build your program. I want you to show me your editor and your simulator screenshots. Okay. And then you can run it. so you can test it. So in the example, it shows you that, you should test it with 6, so you should get 8, right? And when n is 6, you have f of n is 8. And you can set your value so you can check. Try it with a larger number and see what it does, right? Test the capacity of your program and see. Because to me, I think every software has its flaws, right? And how you solve the problem, you can take a look at how you can improve the solution to that problem in the next iteration of that particular software or application. So okay, since you already have the code, I'll leave the pseudocode there. So for the project, we have to start thinking about how you don't have to do console screenshot. There's nothing to show in the console except for halt processor, right? The output that you're gonna see is in the simulator. Okay, so I just need the code from your editor in the simulator. Yeah, the video is an explanation of what Fibonacci is, right? The numbers and the golden number, the golden values. So that just kind of give you the math background of it. So this is, if you look at the lab manual that they use at the university, this is lab 4. Okay. And we would do subsequent lab. There's some lab that, I didn't get to in the last 2 times I taught LC-3 at Moreno Valley College. I might get to it later in this class because we're actually 1 lab ahead. I removed one of the lab that I wrote, and, that requires like Windows system only. So you guys are actually 1 lab ahead compared to the last group of students that went through the class. And then we were in COVID, the beginning of it. So I didn't get to do this with them until I think week 8 or something like that, or week 7. Okay. So in the future, we will use more loops. So look at that section and see how you can further implement it in your other programs. Okay.
Hey, Professor, so by changing n, we could also change the values of a and b, or are we just still 1?
Because so the A and B, that's just the seeding value at the beginning. So the first section of it was just the initial with the if statement. Okay. But when you change the input for the n, right? Because if you look at the equation, yeah, it impacts the A and B value and the f of n value. If you look at this equation in general, that's what Fibonacci is, right? Because n is just the position of that value in the sequence. So if you say n is 1, that's the first number, n is 2, second number, n is 6, that's the sixth number, right? What is the value for the sixth number? So when you look at the Fibonacci sequence, okay, right? So let's say that we start out with 1 is 1, right? When n is 2, right? It's also 1. So it's the sequence actually start after 2. So when you set the value for 6, right? So 1, 2, 3, 4, 5, 6, that should be 8. Okay. The 7th number is 13. The 8th number, right? That should be 8 plus 13 is 21. And be careful with the simulator because remember that the simulator is going to give you hex value. So when you look at my program, right, because I use 0 through 9, so I just use decimal value like what Lewis was asking. So that's fine. You can use hex, but because I'm using the negative sign, I have to use the decimal. So what you can do is when you look at the output, keep in mind that it's giving you in hexadecimal. Right? 0 through 9 is going to be equivalent in decimal. So when we're checking number like on the lower number, that's fine. But when you get to the higher number, keep in mind that it's in hexadecimal. So you can use your calculator to convert, or you can just manually convert it yourself. Okay. Other questions? So, yes, question?
I was running it real quick, and I was just a little bit confused about where exactly we're supposed to look to find that number, the hex value number. Would it be in the 4th register?
You're not going to see it actually store out and it changes. So you're not going to see the A and the B. You're going to see, because we didn't store out for we only store out for the N, the one that has the label.
Mm-hmm.
So your N is actually the position of that value. And your B, your A and B is, your A is N minus 1 and your B is N minus 2. So we have clear out register and change it throughout our code. So you're not going to have the exact A and B. You're only going to have the position, which is your nth value. Okay? Because if you look at your code, if we really wanted to see A and B, we have to store out from register 2 and 3. Okay? To a label and a location. Okay? Because in both section for the FAB and FAB2, we didn't really store out for register 2 and 3, so you're not going to see A or B. They were just vehicle for you to get f of n. Okay? But at the beginning, we did have in the criteria, right, it says that this is equal to this. So what we have to do is we have to set that up so we can set up our loop. Sorry, I just lost internet connection and it took a few minutes for the router to restart, so. Little spotty internet in my neighborhood about this time. So yeah, the video would just still be the same because it's already in session. So you guys don't have to worry about that. It just, I'm gonna get dropped off and then I will get like 2 logs for the session from Zoom. Okay, any other questions?
Oh, Professor, so the main point of like the code is to show like the value of like the number placement for n.
Not just the placement for n, but the value itself. Yeah, the value at that position. You're correct.
So like if we were to put n is equal to 0, then it print 0.
Yeah, because remember the sequence, so we start at 1, we seed at the n is 1. So anything before that, it's not gonna go, right? But you can check like when n is 12, what's gonna be your f of n, right? 12 as in 12 decimal. So you need to, if you set it as hex, you need to convert that, okay?
It's a little off topic, but also kind of correlating with the program we just did. But when you want to print something in console without like doing input and output, can you? You just need to
You
use
have to ASCII convert it.
Oh, that's fine.
Yep. So before you have it put to show on console, you have to ASCII convert it.
So like towards the end of our program, if we did want to show it on console, we just change that value to ASCII and then.
Yeah. So so what happens is, remember that you store it to a label, right? But if you don't want, if you want to display it in console, you need to ASCII convert it and then move it over to register 0. Then you can do a put. So that's probably like 5 more lines. So you wanted to show f of n, right? So that means that when you store out for the f of n, you want to store it to that memory location. However, before you store it out, you want to ASCII convert it, copy it to register 0, right? After the conversion, and then you do a put. So that's 1, 2, 3. Yeah, like about 4 or 5 lines. So you can just do like an offset of 48. So you subtract. Remember how we did that in like 2, 3 labs ago we did? So you can do the offset by subtracting 48, copy it, the register that store f of n to register 0, and then do a put. You should still store out because that's what the label and the memory location is for. So that way it's permanent. Instead of keeping stuff in the register, it will go away. Okay. So if you want to really display a series of number, what you need to do is you have to put continuously, right? Like if I wanted to show a sequence together like this, okay? C++ is really easy, right? Iterate through the, put it into a dynamic array and then loop it to print each of the index. But for LC3, you have to ASCII convert it, copy it to register 0, put for every single one of them, unless you store all of these into a block and then create a loop to access each of the offset where it holds the value and then put it. So in my opinion, right, it's the same amount of code either way. so you're looking at like 5 lines for each of the values. But if you store it to a block and then you write a label to loop and index it to access each of the value at that memory location, it's still the same amount and you still have to ASCII convert it. So LC3 is something that we don't really do like the user output so much. It's low level. So you have to think about, oh, this is what we see with just numerical value. This is what the processor sees. And, we write instruction for the processor. So that's why I show you how to do the put so that way you see how it works with like hardware. In the case of display monitor, and then with the keyboard, when it register something that you input, you have to tell it to tell the system to encode it. So when you do ASCII conversion, you're doing encoding manually, right? Other questions?
So if we wanted to test a value, for instance, like the number 55, would we have to change it to hexadecimal to work with it?
Ideally, you should. By practice, you should. Okay. I've tested it with the decimal. You just got to put the hash in and it's able to give me that, but it's going to output hexadecimal, right? Because the simulator, its job is to convert everything to hex and binary. Okay, so let me reload this program so you can see. And then let's say that I wanted to do hex 3100, right? And, in the larger number scale, you're going to see. So here, if I put in like position 30 for my n, right? See how it tells me invalid value? So you have to set it with a hex, so you have to convert it. So with the lower number, it's easy for us, like 9, 0 through 9 is okay. But when you get to like the next one, so if I wanted to do the 10, I'll just do an A like this, right? Or a B for 11. Okay. And then I run it and then I jump to it. So there you go. So what does this mean? What this program needs is if you scale out this program, remember that when we're looking at the value, we're only going to be looking at one value for that n position, right? F of n is at, is this when n is this. Okay. It does not give you an array of values that represent the sequence itself. So if you wanted, like I said earlier, if you wanted to implement the array of that, you have to allocate the memory to really store that. And when you do that in C++, the compiler handle that when you declare the array and you say, oh, every time that it generates a number, it's just going to put it into the array so we would see a sequence. In this program, it's exactly like my C++ program where it's only going to show the number for f of n. Okay.
Thank you.
You're welcome. So it is lacking to really show. What I'm telling you is it's not displaying a sequence. It's just displaying f of n and the max of f of n. And also because our word is 16-bit, so you do run into limitation, right? In the way that we allocated these labels. Later on, we would write stack and so that way we would use like a group of memory locations to kind of push and pop things, right? So you can push values in, store it there, And then you can pop values out. So you see some of that later on in the future labs. Other questions? Today is we finished super early. I should have given you 2 programs to do, right? But I'd rather you understand the program and look at it closer so that way you know how to write it in the future than just give you a lot of work, right? Quality over quantity anyway. So let's see. So since you're here, let's see, I got 7. So in the next lab, I think I have the old one. You guys are gonna do the lab 5 in the manual. So we're gonna do division and multiplication next time. So this would teach us a little bit more on JSR and to call subroutine, like how you would call a function in C++. So, and then we would use mod a little bit more, okay? So next lab is gonna be a little longer, and then we have to branch and do a little bit more tweaking with the LC-3 program, but it's definitely doable, okay? So that's going to be our next lab. You can just continue to read the next chapter in the text if you wish. I recommend in this class, I'm going to tell you this, okay? Everybody that you talk to that take assembly, they're going to say that it's hard because it's different. But organizational and architecture type of classes, you have to really do reading and, you know, dig a little bit deeper and do some research in addition to that. At the university level, a lot of the time they teach this class with digital logic and that's it. So, you know, like for example, at Cal State San Bernardino, they teach it with MIPS, which is a different type of processor compared to what LC3 really uses. So, you know, and you would have to read like a really big book and it talks about like, you know, the components in the processor, how it handles the processes and so on. So I encourage you to read, especially when you start with like more of the upper division computer science classes. The context of it is going to get a little bit more complicated. Concept is going to be covered quickly with lectures and things like that, and they will not go over the labs like what you've seen. So, you know, getting used to this concept and be able to do a lot of the stuff like on your own. And I hope that when I walk you through these things is not because I want to, you know, hold your hand all the time, but I want to explain it to you so you understand it and making sure that you know how to do this for our project. And also if you need to use it, you will be able to do that, right? So apply it. So, and assembly is either you love it or you hate it. So a lot of people, they don't like it because, you know, I totally love it because I see it. It's really easy for me. And programming languages, you know, I can look at documentation and I see it. So I can look at like a library and I can say, oh, okay, I can use it for this. But, you know, if you have a good foundation, it doesn't really matter what language that you're using. You should be able to grasp it. So I hope that these classes that you're taking with me give you at least the basic foundation so you can understand the concept and apply it across languages. Okay, so any other questions? Okay, so if you don't have any questions, if you're finished, you can type in the chat your name. That way I have a record of it in case they ask. I'll stick around for questions if you have questions for me. And I should have a little bit more time to put like internship stuff in your class. I have, also I will post some certification things. So take advantage of getting your certification, especially with Java and C++. Have that on your belt. That way in the future, if you need to tell employers that you have that. So I will post a flyer in the upcoming week and then you can sign up. It's free for you this semester, this year, okay, through Microsoft Certiport. Okay, have a good night if you're done. If not, if you need help, let me know. Thank you, good night. Let me stop recording.